All right, hello everyone. This will be the first video in our unit on finance, and I'm going to kind of do a mashup with this video a little bit. I'm going to throw in a couple of simple interest problems, but considering that those problems were not intended to be all that difficult and pretty simple to follow, I've decided I'm not going to do like a whole big video on that, and instead, we'll just focus on solving um, some of the problems involving the more complex compound interest. And then future we'll get into loans and deposits and everything. But I figured at least we can do a couple of the simple interest problems just to make sure that um, you understand the basics before we get to the more complex things. So we'll start by doing some of the same examples that we did in class recently. And you will have this big warm-up problem to start. So here's your first question. Using simple interest, how much money must you deposit into an account if it bears 4.3% interest annually so that it will be worth $5,000 in 3 years? Okay, remember that our formula that we're going to use is P times 1 plus RT equals F. And so these letters, remember, F stands for future value. P is present value or principal. R is the rate, and T is the time. The whole idea of the 1, why do we have this 1 plus in there? Well, if you recall, the reason for the 1 is it represents the original value um, of the loan or the deposit. In other words, the principal value, but at a factor of 100%. Remember that if we distribute the P in this and we have F equals P plus PRT, remember that to calculate future value, we have the original amount P plus the amount of interest that is calculated. So the interest is, the rate forever how much time we have for every dollar that we have. So that is calculated as P times R times T, but in practice, most of the time what we do with that interest is we add it back into the total amount. And so that's what that P represents, the total amount. When we factor it out, it becomes a 1. And so essentially that 1 refers to the fact of that we have the original amount that we're trying to keep in the account. So if you think about it like taxes, right? Suppose we had a $30 sweater, okay? And the tax rate, and so the tax rate is 6.35% in Connecticut. So if you want to calculate that, you can simply multiply $30 times 0.0635, but then you'd have to add that back into the $30 so that you know exactly how much that's being paid. Um, you don't need to know, usually in most cases, you don't need to know the separate amount of tax. You want to know what the total bill is going to be. So what you can do is you can just take 30 and multiply by 1.0635. And that 1 represents the original total of 30 and says, hey, I'm multiplying by a number greater than 1 so that the amount goes up. Otherwise, the amount goes down. So think of it that way. Okay, so let's erase that. Oops, F equals P1 plus RT. Perfect. There we go. Okay, so now that we have that, let's take a look at a few problems, shall we? How much money must you deposit into an account that bears 4.3% interest annually? Oh, anyway, I've reread the problem already. So let's think about this. We have F equals P equals R equals T equals. Remember, the whole setup of these problems is you're going to figure out which variable are you solving for, and then figure out what the other values are that we can plug in so that we have an equation that we can solve. So what variables do we have? Okay, well, let's start off with the ones that are the most obvious. 4.3% interest annually, so 0.043. 3 years, so T must be 3. Now, we have this amount, $5,000. Is that the present value or the future value? Okay, So it will be worth $5,000 in 3 years. So that must mean it's in the future. And how much money must you deposit into an account now? So you can kind of see um, the hidden word now there. Um, so now we can take a look by saying, I'm getting email messages. Okay, so now we take a look and P, we'll just leave as P. All right, so 5,000 equals P times 1 plus 0.043 times 3. Okay, well, this is just 0.129. So 1.129. So 5,000 equals P times 1.129. And then all we have to do is divide. And so I just take my trusty calculator. Let's clear that out. And I'm going to do 5,000 divided by 1.129. And I get 4428.7. Okay, one thing to keep in mind, I don't know if you guys can see my calculator or not. Sometimes you can, sometimes you can't. So anyway, um, the amount that's actually shown on the calculator with the decimal places is 4428.6979. Well, in that case, it makes sense to round up to 70, right? But in most cases, when you're dealing with both loans and with financial accounts like this, it's always helpful, even if the number is less, if that last half a cent is below zero point 0.5, it's helpful to round it up anyway. And the reason for that is in the case of this, if we left it, say, at 4428.69, if we round it down, that number would technically not be enough to get to $5,000 in 3 years. You'd end up with like 4999.97. And I guess, yes, that's kind of fine. Um, but technically, that's not $5,000. So will I nitpick on that on quizzes and tests? No, I would not do that. But logically speaking, if you want to be as precise as possible, you would round up. When banks hand out mortgages and loans and they calculate a monthly payment, um, they will also round the monthly payment up like that to ensure that the final payment isn't higher than um, all the previous payments. You want the last payment to be lower. That would just be good business practice. And we'll talk about that when we get to loans. So, when in doubt, round up at the nearest cent. But again, you can round to the nearest cent, and that, for grade purposes, that's not going to matter. Just giving you a little bit of logic behind it. All right. Same thing here. You borrow $500 from your parents for a new video game console. You agree to pay back the money in 90 days, plus the equivalent of 5% annual interest. Okay, how much will you owe? Well, let's see, $500. Let's write it out on the side, right? P, F. I'll just go ahead and erase that. Let's start over. We'll just do FPRT. I like to do it in the same order when possible. Okay, F equals P equals R equals and T equals. Okay. Okay, so once we have this, let's see. You borrow $500 from your parents for a new video game console. So that must be what we start with, $500. Okay. You agree to pay back the money in 90 days plus the equivalent of 5% annual interest. Okay, 90 days. So 90 days, what we could do is I could say, well, 5% annual interest, because it's annual interest, we want the time to also be expressed in an annual term, so years, right? So we're going to do this as 90 over 365. Now, you could say, oh, that's 3 months, that's, a quarter of a year. Yeah, you could do that. 3 months, quarter year, you could. but we're going to be a little bit more exact here. Okay, so 500 times 1 plus 0.05 times 90 over 365. Okay. All right, F equals. So here, no solving. All we have to do is evaluate this function. So let's go ahead and do that. Let's do 90 divided by 365. I'm going to start with the actual fraction itself. 0.2465, add 1, and then multiply this by 500, 623.29. So my final result here, 623.29. Okay, and again, that's in terms of simple interest. Okay, great. So again, not too bad. Let's do one that's slightly harder. Okay, there's a particular kind of account where, this is some of the more risky of the loan systems. If you've never heard of this, a payday loan is a small loan usually taken to pay other debts that you normally wouldn't be able to pay before a paycheck. As you can imagine, this sort of system is essentially targeted at people living paycheck to paycheck, the ones living like at or near or even below the poverty line. The charge for this type of service is not an interest rate because the amounts are very, very low. Instead, it's a flat fee. Um, but in many ways, that is way, way worse, as you'll see. So if we were to do an interest rate, most of these loans are very small. We're talking a couple $100s. So essentially, a person who needs money to do something before they get their paycheck at the end of the week, they can go to, say, Monday or Tuesday if they get paid on Friday. They'll go to a store on Monday or Tuesday and they'll ask for this kind of loan. And they'll say, okay, well, you can pay us back, next week. Pay us back. If, let's say, your paycheck is, say you get a paycheck for $500, okay? If you get a paycheck for, say, $500, they'll say, okay, we'll loan you $430 right now, but then you owe us the full $500 when you come back. So they're charging you $70 for the service. And that's a pretty good chunk out of the 200. But here's the thing. People who are in this situation are there because they can't afford extra expenditures. And this $60 is yet another extra expenditure. So what makes you think that they're able to pay it? And in many cases, they're not. So what they do is they take the $60 and they take out a loan to pay for the $60, and then they take out a loan to pay for that, and then a loan to pay for that, and then a loan to pay for that, until they can't take any more loans out. The system collapses. And what they do is they rack up thousands of dollars in these sorts of service charges, and then the company sues them. And they don't get all of it, but they certainly get a lot more than $60. And it's an extra unnecessary hardship and on people whose only crime is they're just struggling to pay for money. So it's a terrible system. And thankfully, there's been a lot of laws passed to limit this behavior, um, which is good. So let's answer this question here. Suppose you need to borrow $200 for a 7-day cash advance. Okay. So P equals 200. Okay. And the service charge is $60. Okay. So what does that mean? You borrow $200 for a service charge is $60. So at the end, what's going to happen? At the end of the time the loan comes due, how much are you going to pay? You're going to pay a total of $260. The $200 plus the service charge of 60. Okay. The rate here is, well, we're going to find that. But the time, here's the time. It's a 7-day loan. So much like the previous problem, 7 over 365. So 260 equals 200 times 1 plus r times 7 over 365. Now we have to solve for r. So to undo the fraction, we're going to leave it as a fraction. This turns into a wacky decimal. Let's not deal with that decimal. Instead, we'll just deal with it directly as a fraction. We're going to divide both sides by 200, and that's going to give you 1.3 equals 1 plus r times 7 over 365. Subtract the 1. And then finally, how do you get rid of a fraction? Well, you get rid of a fraction by, oops, that was not what I wanted, by multiplying, no, by the reciprocal of 365 over 7. And on this side, 365 over 7. So basically all I do is I take 0.3 times 365, divide by 7, and I get 15.6429. Now at first, you're going to be like, okay, that's a 15% loan. That's kind of high, but not out of the question, right? But wait a minute. Didn't we say that R is a ratio of a rate? And when you do math with it, it's represented as a decimal, not as a percentage. So guess what? This 15 is a factor of 15 times, which means this R is actually 1,564.29%. Youch. Wowzers. Okay. No wonder there's a problem here. This is the same as almost 1,600% interest. That's why they were cracking down on these. You would not go to a bank and get a 1,600% loan, that's for sure. So why should these guys be able to do it? Yikes. Okay, so that covers some basics of some of the simple interest part. Okay, so I'm going to stop this video here and add some practice problems there. And then we're going to pick up again with compound interest in just a second.